So it's asking you for the equivalent expression for 3x squared minus 5x minus 2, which means factor. They want us to factor it. Now, A is not 1, so we need to make a box. The factoring question on the test was kind of rough. Well, not kind of rough. It was rough. So we need to remember how to factor because it's going to be on every single test. Every single test we have this semester is going to have a factoring question. If somebody asks me what's the most important thing that you need to know in high school, if you're going to take any kind of math in college, it would be factoring. So we have to know how to factor. That's the most important, one of the most important skills. All right, so the first term goes here. The last term goes here. Let's make our x. On top of the x is the first times the last. Go ahead and multiply those. Take 3 times negative 2. Put that number on top. The middle number goes on the bottom. All right. Now you need to find, this is the hard part. You need to find two numbers that multiply to give you negative 6, but add to a negative 5. Anybody need a calculator? Okay, what numbers you come up with? Still thinking. What are some numbers that we can use to multiply to get 6? 1 times 6, or what else? 3 times 2. So when you subtract 3 minus 2, what do you get? What's 3 minus 2? 1, right? What's 6 minus 1? 5. So I know I'm using the 6 and the 1. And I need to figure out which one is negative. So I'm using 6 and 1. The bigger number is negative in order for me to get a negative at the bottom. So let's go ahead and put a negative 6x and a 1x. Okay. 3 and 6, both of these numbers can be divided by 3. So I can take out a 3 and an x right here. The only number that goes in 1 is 1. So this can be a 1. And it's going to be positive because this is a positive 1. It matches the sign. All right. So now that I got my start, this has to just be an x. How do I know that? Because 3x times x is 3x squared. And 1 times x is 1x. All right, what about this second column? What do you think I'm taking out of 6 and 2? A 2, good. Would it be positive or negative? Negative, because it's on top of a sign that's negative. So my equivalent expression would be 3x plus 1 and x minus 2. These are the exact same expressions. These mean the exact same thing. The graph is the same. Everything is the same. All right, so now we're going to talk about graphing exponentials. So what is an exponential function? Just know that exponential function means that we have a changing exponent. That's all that means. Exponential, changing exponent. Now, what's tricky about this one is that we all know about AH and K, but now I'm adding one more thing, and that's B. B is the base of your exponent. So let's go to our transformation. Well, actually, let's do this first. Let's go to page. Let's fill this in first, and then we'll go back. All right, so just like before, A is still in front. A does three things. When it's negative, it reflects. If it's bigger than 1, it makes it stretch. And if it's a fraction or decimal between 0 and 1, it makes it compress. So that doesn't change. All right, then we move on to H. Okay, H is in the exponent. You know how in the square root it was underneath the square root? Now it's in the exponent, okay? And we still flip the sign. If it's positive, it makes it move right. And if it's negative, it makes it go left. K is in the backyard. K moves it up and down. When it's positive, it moves it up. When it's negative, it moves it down. And then lastly is the B value. This is new. The B value is the base of your exponent. Okay, the base of the exponent, if it's greater than 1, that means it's going to be exponential growth. And would you agree that if something is growing, that means it's getting bigger? So that means it's going to increase. This is what an exponential growth graph would look like. Go ahead and sketch it. This is what it looks like. A backwards L. That's the growth graph. And if it's less than 1, it's going to decay. Exponential decay. This is what an exponential decay graph looks like. So we have 4 things now. A, B, H, K. And this function, the most important is K. K is going to control the domain. It's going to control the range and the horizontal asymptote. Okay, so now let's go back. This is just a parent graph. And this graph, B is 3, which means it's going to be a growth graph, which means it's going to increase. That's what growth means. The number in front of 3 is 1. The number in the exponent is 0. And the number in the backyard is also 0. Okay. So K value being 0 means that, I'm going to draw this in, is actually right on top of the x-axis. This right here, that's the lowest the graph is going to go. Your domain is always, let's go ahead and write, always negative infinity to infinity. Your range is always K to infinity. No bracket, parentheses on both sides. So because K is 0, it would be 0 to infinity. And you have a horizontal asymptote at y equals 0, which is y equals K. We only need one of these tables. So let's just do our X and Y. And let's plot 1, 2, 3. Actually just 0, 1, 2 because 3 won't fit. All right, with your calculators really quickly, I want you to type in 3 to the power of 0, 3 to the power of 1, 3 to the power of 2. It's exponential, which means I'm changing the exponent. Anybody need help putting in an exponent? It's the little upside down caret key that's under the pi sign. That's how you change the exponent. So 3 caret 0, 3 caret 1, 3 caret 2. Did you get 3 numbers? Now, anything to the power of 0 is going to be 1. So this first one is 1. 3 to the first, 3. 3 to the second, 9. So let's go ahead and graph it. So I got a point here. At the 1, I'm going up 3. At the 2, I'm going up 9. So this is what the graph is going to look like. And it gets really close to their asymptote. That's what that's what our graphs will look like. I was trying to think of what to describe that as. The only thing I could think of is a backwards L. Should look like a backwards L. So that's the graphs we're going to focus on for this chapter. All right, any questions about that? All right, now let's go to our next page and let's start identifying transformations. So this was the struggle in first period, so I'm gonna try to do a little different. So we have to figure out, and we're gonna use the choices more than once, okay? All the transformations for each function. So let me help you out. Can you write that these two, those two go with H? And then these two, those go with K. And these three all come from A. Because remember, A can do 3 things. And the last one is the new thing, B. That B value, depending on what it is either going to make it grow or decay. So hopefully that helps us figure out our answers. Okay? So I'm going to zoom into this first one here. For this first one, can you write, this is A. A is 5. This here is B. B is 4. I want you to look at your answer choices. See if you can figure out the 2 answers. Because A is 5, which one of these pink answers am I going to use? Does it stretch, reflect, or compress? A is 5. What does that make the graph do? Stretch. So we're going to put the letter A. Now B is 4. Is 4 greater than 1? Yes, so that makes it, it's going to grow. So it's A and B. A and H, sorry. Those are my answers to the first one. Those are my 2 answer choices. Tanya? Oh. What should I put? I should have put who? G. No, B. Thank you. Thank you, Tanya. I appreciate you for paying attention. I know everybody else just writing what I write. I'm glad I got one person in here that's paying attention. Thank you. All right, let's look at our second one. Our second one has 4 answers. Okay, this is A. This is B. Now, H is in the exponent, but you flip the sign. So it's not a positive 5, it's a negative 5. And K is positive 5. So I want you to look at your answer choices. Pick your 4 answers. What 4 answers? Starting with A equals 4. What does that make the graph do? B is 1/3. What letter do you use for that? Which one of the yellow do you use? H is negative 5. Which one of the green? K is positive 5. Which one of the blue? So take a moment, pick 4 letters that you think is going to go with this graph. Pick 4. Maybe you want to like open your packet so you can see them side by side. I have a study guide. I don't know what class, but it's just a blank study guide with no name, no period, no nothing. So I'm gonna leave it up there until Friday, and then if nobody claims it, it just goes in the trash. Okay, A is 4. So A is 4. I'm using one of these pink ones. So I'm gonna use stretch. So this is gonna stretch, so B. B is 1/3, which means it's going to decay. So J. H is negative 5, which is going to move it to the left, which is E. K is positive 5, which moves it up, D. Those are your answer choices. All right, now let's go to the next one. So for this one, this is the front, that's negative 1, that's A. The base is 2. Is H positive 5 or negative 5? Who says it's positive 5? Who says H is negative 5? You flip it, it's positive 5. All right, see if you can find your 3 choices. What 3 letters are we using for this transformation? There's 3 choices. A is negative, the base is 2, and H is positive 5. So Bailey, give me one answer. Give me one of the 3 answers that you would use. G, let's see what G says. No, it doesn't make it compress. It's negative. So when it's negative, it makes it do what? Look at the first line we put on the back. When A is negative, what does it make it do? Reflex. So we're going to use C. Isaiah, give me another one. What's another letter you could pick? H is going to grow because the base is 2 and that's bigger than 1. And Maya, what's the last one that you would use? A. I agree. All right, let's look at the next one here. So the number in front, that's your A value. The base is 4. H is negative 5. So there's 3 letters. Go ahead and look at your choices. Flip back and forth. Figure out what 3 options, what 3 transformations you would pick. Okay, Inma, what would you pick? And E? Okay, so G, because it is compression, because 1/4 is between 0 and 1. H, because 4 is bigger than 1, so it's going to grow, and it goes to the left. So I agree with those 3 choices. All right, next one. All right, A is negative 0.3. Let me just pause right there. I'm not even going to do the other 2. 2 of those pink answers, you see those ones I have highlighted in pink? I'm going to use 2 of those because A is negative. That gives me 1 answer. And 0.3 gives me another answer. So there's 2 letters I'm picking because A is negative 0.3. Isaiah, what you think? C? I agree because it's negative. Johan, you got another one? What's the other one? G, because it's a decimal and it's less than 1. All right, the base is 2. Okay, when the base is 2, 2 is bigger than 1, that's going to make it grow. So H. Now, in my exponent, do you notice how that X doesn't have anything with it? That means H is 0. So this one does not go left or right. But that -5, that's K. So K is -5, which is going to make it do what? Down. So what letter is that? F. Okay, last one. Okay, so A is 1/4. Let me pause right there. Look at your transformation box. On the other back of page 1, on page 2. 1/4 is not negative, so it's not going to reflect. Is that going to make it stretch or compress when it's 1/4? Who says stretch? Who says compress? I agree. So what letter is compress? G. Okay. And then we have the B value. B is 2/5. So that's going to be one of these 2. Who says it's J? Who says it's H? So it's 2/5. If you divide in your calculator, 2 divided by 5. Is 2 divided by 5 bigger than 1 or less than 1? Less than 1. So that's DK. So J. All right. Again, H is 0, and now K is +5, which is going to make it go up. So D. All right. So now that we've got through that, let's start graphing. So we're going to graph 2 things. We're going to graph the parent. Oh, before we get there. Okay, so exponential functions have a horizontal asymptote, which means it goes left and right. Let's put our phones away so we can pay attention. An asymptote is an invisible line that the graph does not cross or touch. And that's going to happen at y equals k. So that's really important. So in this chapter, K is the superstar. It's all about K. So let's start graphing. All right, so we got us first, we're going to graph this one here. This is the parent. And the parent, everything is like the original. A is 1, H is 0, K is 0. So let's graph, I'm going to graph it in green. Oops, I meant to start with 0, sorry. 0, 1, 2, 3. All right, so 2 to the power of 0 is 1. 2 to the first is 2. 2 times 2 is 4. 2 times 2 times 2 is 8. Now this function, these 3 are with that function. Your domain will always be this. So always. This is the point we should all get. Your range is k to infinity. No brackets, parentheses on both sides. So in this function, the one that you see circled in green, k is 0. So it's 0 to infinity. Your horizontal asymptote is y equals 0. So when I'm graphing this first one, it cannot cross or touch the x-axis. That's my boundary. So let's go ahead and graph it. We're going to put a point at 0, 1, 1, 2, 2, 4, 3, 8. All right, so we're going to come out really, really close to x, and then it goes up really fast. That's why we call it growth. If I trace the graph, everybody look at the screen. When I trace it from left to right, do you see how it's getting bigger at the end? That means it's growth. It's going to do that whenever your base is greater than 1. So that's the mama. Okay, now we're going to make some changes to it. Okay, looking at this function here, two things change. The first thing is, notice in my exponent, is h going to be +1 or -1? Remember, you always flip the sign for h. +1, which is going to make it go right 1. So I'm going to pause. I want you to add 1 to all of these numbers. And we're going to put it over here in our new table. So we're going to take, we could do this without a calculator. We're going to take 1 plus 0, 1, 1 plus 1, 2, 1 plus 2, 3, 1 plus 3, 4. Now, k changes y. K is in the backyard. K is -2, which is going to move this graph down 2. So I want you to take these 4 numbers and subtract 2. So I got 1 minus 2, -1. 2 minus 2, 0. 4 minus 2, 2. 8 minus 2, 6. So before we finish, let's answer these questions about that second graph. Again, this is always going to be the same. Now, because k is -2, that's going to change my range to -2 to infinity. And my invisible line, my horizontal asymptote, is going to be at y equals -2. So I'm going to draw in a line at y equals -2. So I like to draw it in right here. Go ahead and put in a dashed line to remind yourself that the second graph cannot touch that blue dashed line. So go ahead and graph that second set. So 1, -1, put a point, 2, 0, put a point, 3, 2, put a point, 4, 6, put a point, and then you're going to graph it. And that's your graph. Oops. Okay, one more, and then we'll be finished for today. Now, the next one, go ahead and fill in everything about the parent doesn't change. So everything that we see in green, notice how it's the same parent. So we're using the same table. 0, 1, 2, 3, 1, 2, 4, 8. All of this doesn't change because it's still a base of 2. Actually, all parents have the same information. All right, go ahead and graph that. And remember, it cannot cross the x-axis. That's our parent. All right, so now let's look at this new value here. Notice that when you compare both of these, they both have a base of 2. See, they both have a base 2. That doesn't change. What changes is I put a 3 in the front. So that's my A value. And when A is 3, does that make it stretch or compress? Who says compress? Who says stretch? I agree. Good job. Now let's look at my exponent. In the exponent, it says plus 2. That means H is negative 2, which is going to move the graph left 2. And then the superstar is in the backyard. That's negative 5. That's going to move it down 5. So again, this is the superstar right here. That right there is going to affect both of these that you see highlighted in yellow. So my domain, that's still all real numbers, but because K is negative 5, you're going to say your range is negative 5 to infinity. And then you're going to draw in your dashed line at negative 5. So let's go ahead and draw that in. Draw in the dashed line at negative 5, so that would be down here. And then we got to pick up our calculators, and we have to do some transformations. It's always H plus X. So I want you to add the negative 2. We do not have a lot of room here. But you're adding negative 2 to all of these numbers, so let's go ahead and do that. So negative 2 plus 0 is negative 2. Negative 2 plus 1 is negative 1. Negative 2 plus 2 is 0. And negative 2 plus 3 is 1. On this side, on the y side, I have to multiply it by a and add k. So I have to multiply these numbers by 3 and subtract 5 all the way down. So pick up your calculators, take those 4 numbers, multiply them by 3, and then subtract 5. This is our last question for today. Multiply them by 3 and subtract 5. And the last point is going to be too big because 19 doesn't fit on our graph. So we're just going to fit the ones we can fit. So negative 2 down 2, put a point. Negative 1 up 1. That's here. And then 0, 3, that's here. Let me see, did I pop that right? -2, down 2, -1, up 1, 0, 3. Is that the numbers you all got? I feel like one of mine is wrong. Did you get that too? You got those 4 numbers? You got 7 for the 3? 4 times 3 is 12. There you go. Because I was like, this don't look right. 4 times 3 is 12, and 12 minus 5 is 7. Thank you. Because it just didn't look right. It just didn't look right. So I was like, something ain't right. Okay. Now let's finish it. Okay. So, again, I'm going to come in really close to that horizontal asymptote. Then I'm going to go up, up, and then after that, it just increases super fast. Okay. I'm trying to get to the top, but that's as high as it'll let me go. And that's that. So we're going to practice this some more tomorrow. I know we haven't had school in, 5 days? So we got to get kind of back into it. Can you write on homework 1 that your homework is due on Tuesday? Homework 1, Module 5, Homework 1 is due Tuesday. Tuesday, February 3rd.